Imagine waking up 100 years in the future, cities floating in the sky, AI running the world, and humanity exploring distant galaxies. Sounds like science fiction, right? But what if time travel wasn't just a fantasy? What if the secrets to bending time were hidden in physics, waiting to be unlocked? From Einstein's theories to real-world experiments, scientists have uncovered mind-blowing clues that suggest time travel might actually be possible. But how close are we? Is there a way to break the rules of time? Buckle up, because today we're diving deep into the future of time travel. Understanding time travel. Ever wished you could hit rewind on life? Or maybe fast forward to the future? Well, guess what? Time travel might not just be science fiction. It's a real possibility, at least in theory. The laws of physics suggest that time isn't as straightforward as we experience it. It bends, stretches, and even slows down under the right conditions. Mind-blowing, right? It all starts with Einstein's theory of relativity. Unlike the ticking clock on your wall, time itself is flexible. It changes depending on how fast you're moving or how strong gravity is around you. This means that time isn't an absolute universal constant. If you were speeding through space at near the speed of light, time for you would slow down compared to someone on Earth. So, in a way, time travel forward is already happening, just on a very tiny scale. But what about traveling back in time? That's where things get tricky. In theory, certain solutions in Einstein's equations, like wormholes or cosmic strings, suggest it could be possible. However, there's a major roadblock: paradoxes. Imagine going back in time and stopping your grandparents from meeting. Would you even exist? This is the infamous grandfather paradox that makes backward time travel incredibly complicated. Scientists continue to explore theories like wormholes, black holes, and quantum mechanics to crack the mystery of time travel. But for now, while the math hints at the possibility, technology is nowhere near making it a reality. The question isn't just can we travel through time, it's should we? Forward time travel. Here's something wild. Time travel to the future is already happening. Not in a sci-fi movie way, but in real, measurable physics. We're all time travelers, moving 1 second per second. But did you know that with enough speed you could skip years, even centuries, into the future? Thanks to Einstein's special relativity, we know that time slows down for objects moving at extreme speeds. This phenomenon, called time dilation, has been proven with high-speed jets and atomic clocks. Put simply, the faster you move, the slower time ticks for you compared to someone standing still. So, if you were traveling in a spaceship near the speed of light, years could pass for people on Earth, while you'd only experience a few days or weeks. And it doesn't stop there. Gravity also affects time. The stronger the gravitational field, the slower time moves. Astronaut Scott Kelly spent 340 days in space, and when he returned, he was slightly younger than his twin brother, who stayed on Earth. Why? Because Earth's gravity slows time down for him compared to Scott, who was in orbit. This means forward time travel isn't just a theory, it's proven science. The catch? To truly leap into the distant future, we'd need to travel at near light speeds, something far beyond our current technology. But who knows, maybe one day space travelers will return home to find centuries have passed, while they've only aged a few years. So, while backward time travel is full of paradoxes, forward time travel, it's not a matter of if, it's a matter of when. Backward time travel. Alright, let's get to the real mind-bending stuff. Traveling back in time. Imagine stepping into a machine, dialing in a date, and suddenly finding yourself in ancient Egypt, or warning the Titanic before it sinks. Sounds incredible, right? But here's the catch. Backward time travel is way more complicated than moving forward. Physics doesn't outright forbid traveling to the past, but it throws a bunch of challenges our way. The biggest issue? Paradoxes. Ever heard of the grandfather paradox? If you went back and stopped your grandparents from meeting, you'd never be born. But then who traveled back in time in the first place? It's a loop that breaks reality. Some scientists argue that time might fix itself in weird ways, preventing changes that would create contradictions. Others suggest multiple timelines, meaning if you change the past, you'd just create a new alternate universe instead of rewriting your own. So how could we actually go back in time? One idea involves closed time-like curves, predicted in Einstein's equations. These would allow you to loop back in time, but so far we don't know if they could exist in the real world. Another theory, cosmic strings, massive, ultra-dense objects stretching across the universe that might warp space-time enough to allow for time loops. But there's no evidence these strings exist. Then there's the biggest question of all. Even if we figure out how to travel backward in time, should we? If history could be rewritten, would we even recognize our present? The past might be set in stone for a reason, or maybe we just haven't found the right key yet. Wormholes. If you want to time travel like in the movies, you need something better than a DeLorean. Enter wormholes, hypothetical tunnels through space and time. If they exist, they could connect two distant points in the universe, allowing you to step into one end and instantly pop out in the past or future. Sounds too good to be true? Well, it might be. A wormhole, also called an Einstein-Rosen bridge, is basically a shortcut through space-time. Picture space as a sheet of paper. If you fold it and poke a hole through, you create a direct path between 2 points. In theory, if you move one end at near light speed or place it near a supermassive gravitational force, time inside the wormhole could pass differently than outside. This could create a natural time machine, but here's the problem. Keeping a wormhole open is nearly impossible. The moment anything tries to pass through, it collapses faster than you can say, flux capacitor. To stabilize one, you'd need something exotic, literally. Scientists believe a form of negative energy, which we haven't discovered yet, could hold it open. Without that, a wormhole would be more of a cosmic death trap than a time portal. And let's not forget the paradoxes. If wormholes allowed backward time travel, we'd run into the same problems as before. Could you travel back and erase your own existence? Would the universe even allow that? Some scientists think time travel paradoxes might fix themselves through quantum mechanics, meaning any action you take in the past just creates a new timeline rather than affecting your own. So, are wormholes the answer? Maybe. The math works, but the technology is pure science fiction, for now. The real question is, if we ever did find a way to open one, would we be brave enough to step through? Time travel future prospects. So, we've talked about theories, paradoxes, and even wormholes. But here's the real question. How close are we to making time travel a reality? Well, let's just say, don't pack your time machine suitcase just yet. The truth is, while the math behind time travel works, our technology is nowhere near capable of making it happen. First, let's talk about speed. We know that traveling at near light speed slows down time for the traveler. But here's the problem. We don't have anything that can move that fast. Our fastest spacecraft, the Parker Solar Probe, moves at 430,000 miles per hour, but even that is just 0.06% the speed of light. To time travel significantly into the future, we'd need to reach at least 90% of light speed, and right now that's impossible. Then there's the issue of energy. Wormholes? They need negative energy to stay open, and we haven't figured out how to create or harness that yet. Even if we did, stabilizing a wormhole would require insane amounts of energy, far beyond anything we can generate. Think about it. We're still struggling to make nuclear fusion practical, and that's child's play compared to what time travel would demand. And let's not forget gravity. Black holes might hold the key to time manipulation, but good luck getting close to one without being spaghettified. Scientists theorize that extreme gravitational fields slow down time, but harnessing that effect in a controlled way, that's not happening anytime soon. So, is time travel impossible? Not necessarily. Science is always evolving. A few centuries ago, the idea of flying across the world in hours was unthinkable. Now we take it for granted. If we crack the mysteries of quantum mechanics, advanced propulsion, or even exotic matter, who knows what doors might open? One thing's for sure, the future of time travel is uncertain. But hey, maybe some future traveler is watching this right now, laughing at how clueless we were. If that's the case, drop us a hint, will ya? So, is time travel just a dream, or are we closer than we think? While science has given us glimpses of what's possible, the technology is still far behind, but who knows? Maybe in the future someone watching this video will be the one to crack the mystery of time travel. If you enjoyed this deep dive, don't forget to like, share, and subscribe to InnoVision Tech for more mind-blowing tech and science content. Until next time, stay curious, stay futuristic, and keep exploring the unknown. Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So, while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal. But according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother? You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure. The more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? Let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster-than-light travel? Right now, it's a mystery, but science is always evolving. Who knows, the next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one. Imagine discovering a planet so massive, yet so close to its star, that it completely challenges everything we thought we knew about the universe. What if this planet could support life, but in ways we never expected? Sounds like science fiction, right? But it's real. Astronomers have found a super-Earth that defies logic, and it's closer than you think. What would it mean for the search for life beyond Earth? Could we be looking at a world with the potential for life? Stick around and let's dive into this mind-bending discovery that's got scientists rethinking everything. What is a super-Earth? Super-Earths are a fascinating class of exoplanets that have been at the forefront of astronomical studies in recent years. But what exactly makes them so unique? Let's break it down. Super-Earths are planets that are larger than Earth, but smaller than the gas giants like Uranus or Neptune. These planets are not necessarily made of the same materials as Earth, but they do share some similarities that make them intriguing. These planets are primarily rocky, much like our own Earth, and typically sit within the habitable zone of their stars, meaning that the temperature on these planets could be just right for liquid water to exist. And we all know water is one of the key ingredients for life. Imagine a world that's just a bit bigger than Earth, with the possibility of oceans, lakes, and maybe even life. Sounds like science fiction, right? But this is a very real phenomenon astronomers are uncovering in our galaxy. Super-Earths are typically located in the so-called Goldilocks zone, where conditions are neither too hot nor too cold. While this term might seem a little whimsical, it's based on the idea that these planets could potentially harbor life in a way that is very similar to Earth. They are a bit more massive than Earth, which can influence everything from gravity to the planet's atmosphere. The concept of a super-Earth challenges our assumptions about how planets form and what the possibilities for life in the universe really are. So next time someone mentions a super-Earth, just know that we're talking about planets with the potential to be life-bearing, and they're out there, waiting to be discovered. The discovery. Let's jump into the thrilling moment when astronomers made this incredible discovery, TOI 715b, a super-Earth that's capturing everyone's attention. It's not just the fact that it's a super-Earth, it's where and how it was found that's making waves in the scientific community. TOI 715b orbits a red dwarf star about 137 light-years away from Earth, a distance that seems far but is actually relatively close in cosmic terms. But here's the twist. This planet exists in the habitable zone of its star. What does that mean for us? It means that the conditions on TOI 715b could allow liquid water to exist on its surface. Yes, liquid water, one of the critical elements for life. The discovery of TOI 715b was made possible by NASA's Transiting Exoplanet Survey satellite, which is specifically designed to look for exoplanets that could potentially support life. Scientists are particularly excited about this discovery because TOI 715b is located at a sweet spot, not too close to its star to be scorched, but not too far to be frozen. This makes it a prime candidate for studying planetary atmospheres and understanding what it takes to support life beyond Earth. What's even more intriguing is that TOI 715b is about 1.5 times the size of Earth, putting it in that sweet middle ground that makes it an exciting prospect for further study. So, why does this matter? Well, TOI 715b represents a type of planet that could hold the key to understanding how planets with similar characteristics evolve and whether they could one day support life forms. Scientists are now looking forward to studying this planet in even greater detail. Could this super-Earth be one of the next steps in the search for life beyond our solar system? The discovery of TOI 715b has opened up a whole new chapter in the exploration of exoplanets and what lies beyond our own home planet. The anomaly. Now here's where things get really interesting. TOI 715b doesn't quite fit the mold of what scientists expected. You see, red dwarf stars are the most common type of star in our galaxy. They are much smaller and cooler than our sun, so any planets orbiting these stars should, in theory, be much smaller too. In fact, most of the planets discovered around red dwarfs are either rocky and small, or gas giants. But TOI 715b is something else entirely. It's a massive super-Earth about 1.5 times the size of our planet, orbiting a red dwarf star. And here's the kicker. According to current models of planetary formation, such massive planets should not exist around these types of stars. This discovery is throwing all of our previous assumptions into question. How did this giant planet form in a place where it shouldn't be able to exist? The answer isn't clear yet, but that's what makes this discovery so groundbreaking. It could completely change how we understand the formation of planets. Maybe it's not just the size of a star that determines the size of the planets that orbit it, but other unknown factors. Some astronomers suggest that the planet might have formed through a different mechanism, such as the accretion of a vast amount of material that wasn't initially accounted for. Others believe it could have been captured by the red dwarf star after originally forming around another, more massive star. Whatever the reason, TOI 715b's size and its location in the habitable zone has sparked a whirlwind of new theories about how planets, and potentially life, can exist in places we never imagined. In many ways, this discovery is a cosmic curveball, and scientists can't wait to learn more about how it fits into the puzzle of our universe. Implications for life. Now, you might be wondering, what does this all mean for life as we know it? Well, TOI 715b's potential to support life is one of the most exciting aspects of this discovery. The fact that this super-Earth exists in the habitable zone of its star, where temperatures are just right for liquid water to exist, is no small thing. Liquid water is essential for life as we understand it, and the idea that it could exist on another planet opens up the possibility that we are not alone in the universe. But there's more to it than just water. TOI 715b is a rocky planet, which means it has a solid surface that could potentially support life forms. In fact, it's the perfect candidate for future studies that aim to find out whether there could be signs of life beyond Earth. The size of the planet also plays a role in its habitability. Because it's larger than Earth, it might have a thicker atmosphere, which could help protect life from harmful radiation. This could also make the planet more resilient to changes in its environment. Could there be microbes living beneath the surface, or perhaps advanced civilizations on the horizon? While we don't have direct evidence of life on TOI 715b yet, the fact that it sits in its star's habitable zone gives scientists hope. If life can thrive in the most unlikely places right here on Earth, who's to say it couldn't exist on a distant super-Earth? The implications of this discovery are profound. It opens up the possibility of finding life in places we've never considered before, and sparks a renewed interest in the search for extraterrestrial life. So, while TOI 715b might not have aliens waving hello just yet, it's certainly a place worth keeping an eye on as we continue our quest to answer the age-old question, are we alone in the universe? The road ahead. What's next for the search for exoplanets like TOI 715b? Well, this discovery is just the tip of the iceberg. As exciting as it is to find a planet that challenges everything we know, it's also the perfect jumping-off point for further exploration. There's so much more we need to learn, and this discovery opens up an entirely new field of study. First off, astronomers are already working on detailed follow-up observations. They'll be using instruments like the James Webb Space Telescope to peer deeper into TOI 715b's atmosphere, trying to detect the chemical fingerprints of life. This will help us understand the planet's atmospheric composition, whether it has an atmosphere thick enough to trap heat, and if it could sustain conditions similar to Earth. But the search doesn't stop there. Scientists are already hunting for other super-Earths in the habitable zone of nearby stars. In fact, TOI 715b is just one of many super-Earths discovered, and there's a growing list of planets that might be hiding life right under our noses. What's truly exciting is that every new discovery adds a piece to the puzzle of how life could arise on different worlds. So, while we haven't found definitive proof of life on TOI 715b yet, the door is wide open. Who knows? Our future missions could uncover something that changes everything. We could be looking at the birth of the next great space-age frontier, where we begin to answer the question, what lies beyond our Earth, and are we truly alone in this vast universe? The road ahead is filled with questions, curiosity, and the infinite potential to change the way we think about the cosmos. The discovery of TOI 715b is only the beginning of an extraordinary journey into the unknown. So what next? So, after all this, what can we take away from the discovery of TOI 715b? This super-Earth has rewritten the playbook on what we know about planets orbiting red dwarf stars. The fact that it's not just any ordinary planet but one that could potentially support life is a game-changer in our search for life beyond Earth. We've long thought that red dwarfs couldn't host such massive habitable planets, yet here we are with TOI 715b proving us wrong. But this discovery is more than just a scientific curiosity. It's a reminder that the universe is full of surprises, places and phenomena we can't even begin to imagine. If a planet like TOI 715b exists in a zone we thought was too inhospitable, who knows what else is out there waiting to be discovered? Our understanding of planetary formation and habitability is evolving, and this find is at the forefront of that change. It's pushing us to think bigger and dream bolder. And this is only the beginning. With new tools and technology, we will be able to study planets like TOI 715b in greater detail, and who knows what secrets they might reveal. Could this planet hold the key to unlocking the mystery of life in the universe? Perhaps it's not just a possibility, we may one day find ourselves gazing at TOI 715b through a telescope, wondering if life has already taken root. For now, the discovery of this super-Earth has shown us that the cosmos is far more mysterious and full of wonder than we ever imagined. So, the next time you look up at the stars, remember that the universe is just getting started in revealing its secrets, and we're only scratching the surface. Thanks for joining us on this incredible journey through the cosmos. If you found this discovery as mind-blowing as we did, don't forget to like, share, and subscribe to InnoVision Tech for more groundbreaking insights. What do you think? Could there be life on planets like TOI 715b? Drop your thoughts in the comments below, stay curious, and we'll see you in the next video. Until then, keep exploring the edges of science and technology.